Well, I don't find it. Here we go. 1 second, please. Are you able to see the screen now?
Yes, we are able to see your screen, but your PPT is yet to start.
We're seeing the desktop.
Excuse me? You see the SUNTEC City Fountain of Wealth?
We are seeing
No, we see only the desktop.
Your files.
My God, what's happening again here?
You have to go to the desktop and click on the file in the desktop, not here. I think the file is open.
The file is open, yes, that's what it is.
The file is open and it must be somewhere in the desktop. Click there. You have to click there.
In the desktop? Here, you mean?
Yes, you've saw it? Yeah.
Okay, I did on the desktop. Do you see it now?
No, then you have to go on again you go to it's Thailand. No? Thailand and
Okay.
yeah.
I go to Thailand again.
Yeah, Thailand again and then open the
Okay, I did. And now I go to this file. Do you see it now?
yes, now it's coming.
Okay, okay. Sorry for that. Eventually, oh my God, I mean, something's wrong here. Okay, here we should go now, right? You see it?
Yeah.
Yes,
Sorry
correct.
for the damn thing, but I have to eventually get used to this kind of technology. So what you see here is the original state of the SUNTEC Fountain of Wealth in Singapore. So they called it, at the time being, the biggest fountain of the world. I think they meant the biggest fountain ring of the world. So what it originally consisted of is this copper ring, as you see, and then a central element consisting of a couple of 20, 40 Schaumquell or something similar foam jet nozzles. And, you know, it's a kind of feng shui fountain, so it's arranged within a couple of buildings that form the fingers of a hand. And the fountain is sort of in the center of it. So that's following strictly the old Chinese, let's see, philosophy here. So now what's important here, people believe when they go into the center of the fountain, if the ring is off, of course, and then they touch the rail and go about it, and then they think they can get rich when they go back. So they believe in that, right? Okay, now we were asked, and this was a very, very complex task to renovate this fountain. And what you see here is the basic structure in the top view. So you see there's a huge concrete slab. It's slightly inclined from the center to the, or it slightly declines from the center to the outside of the circle here. And the task here was not to touch the structure. So we were not allowed to go through the insulation, the water insulation. Okay, so we had to keep it waterproof. But nonetheless, it should be completely renovated. Now, first of all, it was an immense task to define the materials, which they later approved, right? I mean, the architects, the local ones. So our dear friends and technical colleagues in Singapore did a wonderful job there. So they picked a nice set of granite, of polished and mud stuff. I mean, very, very nice combination of materials, which suited the fountain really well. That was the first task. Now, as I said already, the waterfall from the ring was kept, and the center element, the foam jets in the center were kept as well, but everything else should come new. So the big challenge was to get the water to the positions where we needed it. I will explain that later in the next coming slides. Okay, we skip this here. And what you see here is the little dots indicate positions where we later had fountain effects, lights and nozzles. So what did it mean? I mean, we had to somehow supply them with water, and there was no chance to just rely on the fact that the water coming from the inside would be enough to fill these little trenches here, enough for pumps to feed nozzles directly out of those little holes there. So we had to organize it in such a way that all pumps are at the perimeter in a bigger trench. And then, of course, we had to draw all the necessary lines from the pumps, I mean pipes from the trench to the various places where we have the nozzles and the lights. And the nozzles and lights, I mean the nozzles are within the light. You all know this kind of concept of a donut light. A donut light has a center opening in which you can place the nozzle, and thus everything is flush with the ground, or in that case with the granite top layer here. This was, in terms of, let's say, planning it, quite a big task. Okay, next slide. Here you see roughly what I indicated. So you got the trench here, a trench of limited depth. As you can see, I mean, the water level was only about 270 millimeters. So you see the pumps here in the trench, and the pump serves the pipe, and the pipe goes up to this little depression here where we locate the nozzle, I mean the rectifying pipe, and of course the LED light on top. I think you understand the concept. So the fountain consists mainly of this kind of Varianaut effect. So we got a Varianaut pump here, you see it here. The Varianaut feeds the water into the nozzle, the nozzle spits up here, and then it's nicely illuminated. The other effect we used are jumping jets, directly located in the trench, and then having this parabola onto the granite slab, and the water then eventually will go back down into the trench. That's the basic concept of the fountain here. And here you can see how it was executed later, right? So all the elements are already in the trench, not wired up correctly yet, but about to. Okay, this is a detail of one of those, what do you call it, depressions here, a blow up. So you see, you have an incoming pipe here. You go down and up again to the nozzle, and then you have a top slab, and into the top slab, the LED light, the donut light type of light is integrated. In this case, it's one of our LED, which we call LED-L nowadays. It used to be LED 320 as a profile ring. Okay, that was one of the details of the fountains here. Now, another detail is we used, and you see at the lower end, you see again a drawing of the whole thing here, right? So the secret here was neat integration, first of all. The second thing was pick the right pipes in order not to lose too much pressure by friction, and still keep a certain dynamics, because if the pipe is too long, the reaction time of the nozzle will be very, very long. All of that was done quite nicely, and we were really pleased with the later outcome. Okay, now amazing job in terms of cabling as well. So a lot of cable had to be drawn here, and if you are interested, we have the details somewhere in terms of DWG or something else, but you know, it's not so important here in this kind of general discussion about the fountain, I guess. Okay. Now there's another thing which we have. We used LED strips. Now strip lights are quite complicated because the interfaces to the controls and to the power are not very simple to do, because you have to bring some quite different materials together, and to find the right chemical composition of each is not so, turned out to be stressful. So we had to go through a couple of cycles in order to come up with the right quality. But what you can see here, yes, you see one slab here and the other one here. And the LED stripe is hidden between in this kind of gap, by this kind of L-shaped metal piece, which we integrated here. So it's very nice. You don't see much of it. You just see the light coming out of the gaps, which in our eyes is a very, very nice effect. Okay, so LED stripes. So here you see the finished thing. You see the water running down from the center in small waves over the granite slabs here. You see first fountain action here. Later, I hopefully will show you a video here about it. And the trenches, as a further detail here, are all covered with a kind of RFP grid and pebbles on top. So only cutouts for the jumping jets. This is, let's say, a cutout for the jumping jet. So in the show later, a jumping jet would come out here and just hit the granite slab here somewhere, and the water would run back. Okay, so I tried to run the video up, it works. If not, let me know, please.
No, you have to again go.
Are you sure?
Can you hear me? Yeah, you have to again go to Talon and then you have to click on the video.
It's not working now, right?
No, here it won't work. You have to go to
Okay.
Talon and then again click on the video.
Here we go.
Yes, now it is okay.
Is there any sound effects are there?
Oh, sound is not coming through?
No, it is not. Sound effects are not coming. I think Ashish, how that for sound, you have to start some other button.
While sharing, there is a tab above that desktop, including system audio. That system audio will needs to include.
Okay.
You can go back and again you can start that.
You have to stop share, and while sharing again, you need to check mark that include system audio.
Okay, let me.
You have to stop first.
Okay. Okay, now we go back to share, right? Okay, now what you say? System.
Ashish.
Include system audio. There will be. You need to mark that and share your screen.
Oh my God, where is it here? I don't see it. System audio, where is it?
Just above screen desktop, there is a small mark of include system audio.
Did you watch that?
Michael?
Yes.
The moment when you share the screen, the moment
Yes.
when you press this arrow,
Yes.
share the screen, there is a little square in the panel where you can include sharing audio system or something like that.
It will come, you know, on the right hand side, upstairs, on the upper corner, somewhere.
Upper corner of the screen.
Of the screen, yeah.
Oh, I get it. Sorry.
Got it? Yeah.
We started from the start.
Okay, it's perfect.
Okay, so that was it for the first part of the presentation today. Sorry for my little misfit here, but you know, I'm not used to work with this kind of tools, right? Is the sound gone now?
No, sound is okay. So I think we should start with the question and
Yes.
answers part, no?
Okay. So are there any questions?
Yeah. Is there any questions today? Because I am having the questions which was asked in the first session where Joe has taken that one. So that time many questions could not be answered that time. So I will ask those questions again. So an audience can put your questions right now so that Dr. Henkel can address it to it. So in the meantime, I will ask the questions which was asked earlier. There was a question that is there any specification for the pump selections?
Of course.
Huh.
Now, let's say when we talk about pumps, you have to know the following. All these renovation projects, like the one you have seen, are only possible when you use submersible pumps only. Because the utmost and most stringent requirement is the not that you do not touch the infrastructure. or let's say only to a very, very little amount. And that makes the whole, let's say, technical planning with dry mounted pumps a mission impossible. So all these projects have one thing in common. The filtration system and the water preparation system, everything is kept in place. All the old pipes are kept in place. But the effects have to come completely new. And you can only do that with submersible pumps.
Yeah, so all pumps will be the submersible one.
All we do in terms of show fountains is with submersible pumps. This is, and the reason why is because it's the sustainable approach. You can keep the infrastructure.
Yeah.
And we have done, I mean, this is one out of a few renovation projects we did, right? All follow the same strategy. The customer wants to keep his basin. The customer wants to keep his filtration equipment and water preparation. They want to not dig out all the piping, the old piping, and replace by new. And that forces a solution which is based on submersible pumps.
So that means for every jet there is a one individual pumps are there?
Yes. So in this fountain, the fountain you have just seen, yes, absolutely. One jet, one pump.
One jet, one pump.
Yeah.
And means the one project which you have shown, how many pumps are there? Means as such in that project?
In the one SUNTEC, about 70 or 80.
70 or 80, that was.
Yeah.
And it will work according to the rhythm of the music, which will then how that is getting managed.
Now, are you asking how do we synchronize fountain action with music?
Yeah.
Okay. Now, what you should know is, first of all these fountains, long before they are realized, are simulated already. So we use a simulation tool in order to simulate the fountains. And now listen, we can program the simulation. And we even can synchronize the simulation with music. So whatever you see here in real has been existing in a simulation a long time before. So when we come to a place, all the software is prepared already, and only, let's say, adaptation to the physicals of the site has to have to be done. Most of the software is written in the dry, nice office already. Okay, yeah. And the synchronization is done with a tool, and it's all based on Synchronom software and on Depends electronics.
Yeah. There is one more point is there, means like that way, because there is a instantaneous jets are getting emerging out. So that that kind of that amount of the water has to be there nearby the pump suction, and instantaneously that say 40 meter or 30 meter the jet is getting created in a very short span of time. So then how the pump is getting selected considering that?
Oh, you now you're talking about how to select a pump for a certain effect?
Yeah.
Okay. Now let's say, can we just stick with a, let's say, 20-meter fountain, right? I mean, you want to create a fountain which is based on on a full jet nozzle which is going up 20 meters, correct?
Right.
Okay. Very simple. You will take one supplier's catalog and look into the data of the fountain of these nozzles. Okay, so if you take our catalog, for instance, and if I open with the
you substantiate that one, you can show your certain workings or the certain photographs or something like that, right? So
yeah, but it's very simple to explain. If you want to have a 20-meter fountain, let's say with a Holojet 68, you know you need about 1,000 liters of water per minute, and you need a pressure of about 3 bar. Okay, so then you look at the curves of the available pumps to you, right? We have about 4, 5, 6 pumps in our catalog which would do that, but any other supplier is able to do that as well. Now, This is correct if the pump is directly close to the nozzle. If it is not, let's say, if it's a dry mounted pump somewhere in a vault or in a technical room, which is 1 story below the whole nozzle and the pool, then of course you have to add 3 to 4 meters to the pressure demand of this thing. So it would not be 3 bar, it would be 3.4 bar, something like that. Then you look how many elbows are in the potential pipe between the pump and the nozzle. Okay? So you would probably end up at 3.5 bar and about 1,000 liters. That's what the pump is defined by, which you have to take. And then you look into the right pump, in the pump curve, and then you pick a pump. It's a very simple example when you have a couple of suppliers on the pump curves of the supplier for his product.
So can any pumps available in the market can justify the requirement?
No, only it needs power, right? I mean, a pump has, now, let's say a pump has a motor, correct?
Yeah.
A pump consists of a motor on the pump part. Okay, so the motor has an electronic power, right? Has electrical power. Then you have the power on the shaft, which is mechanical power. And then you have the hydraulic power of the pump.
Correct.
Okay. And what's in the charts of the suppliers is usually the electronic power of the motor, which you need in order to get this hydraulic power at the pump end. Okay, but the hydraulic power is purely defined by the flow rate, in this particular case 1,000 liters per minute, and the pressure need, in our case 3.5 bar. I mean, we can, if this kind of basic knowledge is needed, we can make another little seminar and teach everybody how to pick the right pump for an effect.
Correct.
But I guess our friend Ridvik in India would be able to answer these questions as well.
Correct.
Wouldn't he?
Yeah, I would try to.
Of course. More questions?
Yes, sir. That another question which was asked last time. At what stage of the project do the waterscape architects need to come in?
Can you do me a favor? Repeat,
Can I
please.
repeat again? At what stage of the project do the waterscape architects need to come in?
Oh, that depends. I understand the question. That depends. I mean, let's say now, sometimes, I mean, the trouble is always when concrete is affected in a project, right? When you have to make provisions for technical rooms somewhere in the underground or somewhere else, right? I mean, so that means you have to define technical room space very early. You have to eventually define piping and everything, and you have to eventually define power of the fountain. So the fountain as such has to be designed quite early if civil engineering is heavily affected by it.
Yeah.
Okay. If it is a fountain somewhere on top of a building or something like that, or in a park, no big deal. You can do it very late, right? But if civil engineering, structural engineering is needed, and if it has to be taken into consideration for foundations and everything, then you have to kick in earlier.
Yeah, correct. Means depending on the location, say it is at a ground level or it is at the top of the terrace, means say. So then there is a wind effect also plays a role. So that also needs to be considered while designing the pumps and its effects.
Yeah, I mean, you have to make provision for the size of the pool. You have to make provision for the size of the piping. You have to make provision for the size of the technical room where you accommodate the electronics and the electronical switch part, etc., etc., etc. You have to think about fresh water. You have to think about wastewater. Everything. I mean, there's a lot of interconnection with the general engineering planning. General civil engineering planning, right?
Now that I understood like that. Now the next point is like that. What are the parameters of water to be considered? It is going to remain same for all kind of fountains, or it is varying from the from one fountain to another, because there are various types of fountains are there. So water parameters remain same, or it is a different from one fountain to another fountain?
Oh, I didn't get that. Can you help me a little bit?
Can you please repeat
No,
the question?
my question is that what are the parameters of water required for various types of fountains? Is it the same, or it is varying from one fountain to another fountain?
Okay, Nevasa quality.
Oh, no. I mean, now you touch the most important topic of all, right? I mean, because water quality is absolutely essential for the maintenance phase of a fountain and for the lifespan of it. Okay, so I can only answer one thing here. Water got to be absolutely clean. You got to keep a good eye on the chemistry. We had all
the fountains, right? For all
all fountains, it's all the same. But no, there are slight differences. If you have a fountain which, let's say, includes a water wall or something like what we call mesh wall, right? Something which contains glass. You want to keep especially an eye on the hardness of the water. Okay, otherwise you do maintenance to your death, right? When it's when you got lime stains on the whole thing somewhere, right? So there are slight differences, but basically water quality has to be everywhere really good. Otherwise you get in trouble with the lifespan of the equipment, and maintenance costs are going up.
Yeah, but certain fountains are getting developed inside the lake. So there the water quality of maintaining the water quality of that lake is of course a difficult task, means like that way, because to maintain, because it is having a very huge quantity. So in that case,
I mean,
there are certain different protocols are there for that.
You cannot imagine what kind of solutions we have already discussed with various customers all around the world. I mean, we had a situation in China where a part of the lake was fenced off. So you kind of create a basin in a basin. So you pump filtered water. I mean, the water quality in the lake as such was shitty. Okay, so they fenced off a part of it, and they pumped in filtered water. And with the filtered water, you can run a fountain then, right? Because you get all the debris out and blah blah blah, right? I mean, there are a lot can be done.
So that means for the lake, that means near fountain, and then water filtration need to be done. That's what we are saying that.
Yes.
But
yes.
Similarly, now say in some fountains are there in the sea, and sea water is already salty waters are there. So and again, apart from that salty water, there is the waves of the water is also there, and the wind pressures are also very high. So what are the parameters which you are considering for designing of that fountains in the sea?
No, you're asking a question of which the answer takes about 2 hours.
So just have a glance of that one, because in 2 minutes, what you can give the glance of that.
I will. That was a joke. Forgive me. We have built a couple of quite complicated fountains into seawater. So now the secret of success, and success is keeping such fountains in a highly corrosive environment, which is not only where corrosion is not the only problem. And you got the marine life problem there, right? All the creatures which settle down on everything you build into the sea, like on a natural reef, right? So the answer is, if you build a fountain into seawater, you have to take care of maintenance. You have to design maintenance into the fountain. You have to design accessibility into it. Okay, we have a couple of examples. I mean, we can show you. That's the most important, but it can be done. You can pick the right materials. You can pick the right stainless steel. You can pick the right, let's see, other alloys. And there are methods of preventing, let's say, or at least keeping marine life creatures at a low level in certain areas. But for that, you have to design the fountain in a correct way.
Yeah, that is it. Now,
this is a very complex topic.
Complex, that situation.
It's very complex.
Now that was for the now outdoor. For if there is a indoor fountains are there, so because of the continuous movement of the water and air circulation, so it will add the humidity inside the room and it will further lower down the temperature. So
Yes.
how it needs to be addressed for the indoor fountains?
First of all, I mean, you got to always have makeup water, right? Because you have evaporation, you cannot prevent it. And sometimes it's nice, right? I mean, evaporation is a nice thing if it's hot, because it cools down by evaporation cooling.
Yeah.
Let's say what's important for indoor fountains is mostly the materials you use for those are much more delicate. You use marble, you use all kind of expensive stonework and cladding, and so here water quality is even more important than for outdoor fountains, right? So it's much more about protection of the environment or the pools and everything than the equipment. So you got to put a special eye on that one, right? But so makeup water, you have to have a source of makeup water. You have to especially worry about hardness. So you might have to use some kind of ion exchanging materials in order to get rid of hardness. Other than that, a normal filter and a normal water preparation to take care of algae and all kind of other stuff, and to keep the pH value in a lovely regime, right?
Yeah, that is it. But do you recommend this hot water for the fountains to create some special effects like fogs or something like that?
We would not dare to use any kind of fountain water to create fog because of the potential trouble with legionella or something like that. We would always use tap water for water fog.
Water fog.
I mean, if we are talking about fine dispersed, like real fog, right? Not like water spray. I mean, that's another story. But if you create real fog, finely dispersed little, the white stuff which really blows away by the wind, is blown away by the wind, we only use tap water for that, and about 80 bar pumps in order to create that with very fine nozzles. Hardness is nothing. I mean, we always say 8 degrees of German hardness is the maximum we accept. So water should not be hard, right? It should not be too soft either. Otherwise, you wash out lime from the materials you use for cladding and stuff like that.
Yeah, thank you. And one more question was asked last time. I think Joe has addressed it or not. I'm not able to remember. So when should we go for concave or convex design, and at which place we should prefer such designs?
Did you say vex design? Yeah. You mean when should you go to use a DMX controller for the electronic control?
No, it was a concave and convex design. I think in one of the project which was shown in Mexico Temple Park, where there was a thought of putting
yes. I remember. I think that answer I already gave in that time. We spoke about a specific project, the concave and convex fountain.
Oh, concave and convex. Okay.
It was a project that was on my presentation, but this answer was already gave.
You already got. That's there was one question. So and now one more. This for indoor fountains. What are the regular water care to be taken?
The water care.
Water care means like that we water
yes.
that.
Well, what we use is mechanical filtration or sand filter. And we use a clear fountain system, which means dosing, right, of chemicals. Okay, and this is, under the assumption that there is no problem with the hardness. Otherwise, you need an ion exchanger as well to get in the right hardness regime, right?
So, as such, these were the questions at that time. Now, if anyone is having any questions, to unmute yourself and ask the question to Dr. Henkel, because we'll not get the opportunity to ask these questions again and again. So now this is the right forum and time to ask any questions related with fountains. If you have any query, you can
I like to ask one question. Dr. Henkel,
Yes.
when you operate a jets, right? They are shooting up from the nozzle.
Yes.
Lights is not light is not getting illuminated immediately. Either it is getting illuminated before or when that jet nozzle goes down. That time, how you calculate the delay in that? Delay in the operations of the water jet and light.
Look, light is immediate, more or less. And for a human being, and the reaction time of a human being is eye, light is very immediate. So if you tell the computer says light on, the light is there, right? But the nozzle, of course, let's say if you want to shoot up a jet to 20 meters high, it takes about 1.4 seconds, right, to get up to 20 meters because of gravity. And it takes another 1.4 seconds or 0.5 seconds to get down again to zero, right? So, but this is always the same. So you have a systematic approach here, right? So you know exactly if you want to illuminate when the thing is at the top, you know exactly at what point of time you have to switch on. And with our way of controlling it, you can later adjust within milliseconds the timing.
Okay.
With our control software.
Okay.
Otherwise, you could not synchronize that. And now the beauty is, imagine you have a row of 20 of these nozzles, right? And you want to create a wave effect, and you want to illuminate it in the right time. All this can be done by our software totally automatically. You can automatically create waves with it. I mean, don't get me wrong here, to talk about the electronics and the potential of the control system takes another couple of sessions here. This is for specialists only, and it would not be me doing it. It would probably be Marco or somebody like that, one of our colleagues.
Okay. Okay. Thank you.
You're welcome. More questions, please.
I think there is no more questions. If any question is there, please do ask. Request to this one by unmute yourself and ask any questions. I think Prashant, there is no more questions. So let us have the vote of thanks and close the session.
Okay, sir. I like to thank every attendee, the team from OSA, and the team members of IPA Nagpur Chapter for being present in the webinar today. Especially thanks to Dr. Henkel, who has given us such a nice explanation for all the aspects and calculations and designs of the fountain. Thank you very much.
Yeah, one more request. I want that all the participants are there. Please start your videos and we can have one group photo. All are requested to. Yeah. Thank you so much.
Thanks for listening. I think we will be back one of those days.
Yeah, very sure, sir.
Yeah.
Anyway,
thank you very much. Bye. Ciao.
Thank you. Bye.
Bye.
Thank you.
Yeah.
Happy weekend.
Bye.
Happy weekend.
Yep.
Have a nice weekend.
Same to you.
Bye-bye.
Same to you.
And tomorrow we are having our Independence Day.
Yes, and happy Independence Day also. Yeah.
Thank you. Thank you.
Thank you, Aditi, and same to you as well.
Thank you. Thank you. Bye.
Bye.
उसने बोला कि अपन सब मान लिया एग्जैगरेट करता ही है।
हेलो कहाँ गए? सनसेट है ಇದು ತಲೆನೋ
एक बार आप बात कर रहे
काय के लिए
साहब तो बोलो एक बार शायद ऑक्सीजन मीटर का बोला था
बहुत अच्छा चलिए
ऑक्सीजन मीटर के दिनों पहले बात
देखो वो CO2 टूल में लिखा हुआ था कि डिजॉल्व ऑक्सीजन मीटर होना चाहिए उसके हिसाब से उस टूल के कंप्लेंट्स के वो एक ही पॉइंट था अपने पास बाकी तो जलेगा कुछ नहीं था उसके कंप्लेंट्स के लिए कोड बोला है तो वो पीछे लग गए अभी की यहाँ की हालत देख के तो कुछ कर ही नहीं सकते मैं कल लगे तो उसको मेल भेज देता हूँ एज ऑफ नाउ इट हैज बीन पुट ऑन होल्ड फॉर नेक्स्ट 6 months पोस्ट करता हूँ
पूछते हैं वो सी फॉर्म बोलते हैं तो वो बोलते हैं कौन सी कंपनी से असेंबली वाले पूछ हैं क्या मतलब हाँ
कंपनियों के नाम ढाका उड़ीसा
नहीं वो भी बोल रहा है जो भी है वो तो मैंने पूछा तब बताया उसने थोड़ी बताया था और आज भी वो नहीं मालूम वो मेल कहाँ से जनरेट हुआ है हैक लिखा हुआ है हैक कोई दुनिया नहीं जानता कि हैक कौन सी कंपनी है उस कंपनी का नाम कहीं नहीं आइडेंटिटी कहीं नहीं है तो मेल जनरेट कर रहा है नीचे नहीं समझा मैं नागपुर ऑफिस में भेजा तो उसके बाद तो बोलता है कि कौन सी कंपनी पहले वो बता दो मेरे को नागपुर मतलब ओल्ड असेंबली को भेजा कौन सी कंपनी पहले नाम तो बता दो हैक बोलते तो वो कौन सा हैक बोलते ऐसा पूछते हो पांडे जी वाला गवर्न कर लिया उसके बाद कहा कि कौन सी अब हिसाब पूछते गए तो आई रहा रमन्ना का हिसाब तो भी भेजा सलभ के चबूतरे को क्या नाम है रोहित रोहित दोस्कर तो वो और खड़ा कर कर लिया है वैसा है वैसा मैंने कहा देख यार मेरे को नहीं समझ आता मैं मेरी भाषा समझता इतना है इतना टीडीएस है इतना असेंबली की बुक्स में आ रहा है नहीं आ रहा पहले वो पता होना चाहिए कुछ भी बनाता रहेगा उन्हें टीडीएस काटा नहीं हमने काटा मेरे को तो तेरे बुक्स से कहीं नहीं दिख रहा टीडीएस काटा हमारी बुक से कहीं नहीं दिख रहा टीडीएस काटा नहीं कटा तो बिना बुक होगा ही नहीं मैं बोला उसको पेमेंट ही नहीं हुआ मैं तो जा रहा हूँ
देखो तिलक नगर में डॉक्टर था उसका नाम याद है क्या आपको
कौन सी सब डॉक्टर का याद है
नहीं वो बांते को अपन लेंगे
हाँ
और
मैं ऊपर भी आया उसको मैं उसके बाद ऊपर भी आया मम्मी को लेकर गया ऑपरेशन
हाँ वो तो आप बताए थे
नाखून के लिए लेकर तिलक नगर बोलते हैं उसको क्या बोलते हैं
तिलक नगर ही है
मनीष
नाम
का तो वो है
स्पर्श क्लिनिक है
स्पर्श
मैं स्पर्श हाँ
डॉक्टर का नाम
डॉक्टर का ही बता देगा
स्पर्श क्लिनिक बोलने के बाद
इस नाम से बहुत क्लिनिक है
स्पर्श के नाम
भाई वो वहाँ पर वो ही एक ही निकलेगा यार
No, but I know that location tentatively. I wanted to know the name. In case भूल गया तो किसी को पूछना.
मम्मी को लेके गए थे पैर के नाखून के लिए.
I also.
ये रहा पिपले.
डॉक्टर का नाम.
नंबर भी है. पिपले पिपले.
करते अच्छे लगे.
फर्स्ट काम. काय का डॉक्टर था, तो ऑपरेशन करने वाला था.
हाँ नहीं वो इसका है कॉस्मेटिक वाला है.
कॉस्मेटिक सर्जन है.
प्लास्टिक सर्जरी वगैरह करता हूँ.
सर्जरी करता हो, कैसे भी आ रहे तेरे कैंसर पेशेंट ये वो
एसिड अटैक ये वो सब संभालना.
पिपले. इसकी डीपी में ये लगा. फर्स्ट डॉक्टर पिपले लिखा हुआ मैंने. नहीं यार ये उसके लोगो में लगा है बेटा. दूसरे स्पर्श को थोड़ी अपनी लॉगबुक में डालूंगा भाई.
But he was very costly, na?
No. Not costly. जो भी लिया मैं तो मम्मी को ले गया था. मुझे नहीं याद थोड़ी रुपए क्या दिए क्या ज्यादा हो गए. बहुत छोटी चीज के ले गया था.